Hello, 8th graders. Welcome to distance learning. So how this is going to work is that I'm going to go through all the slides for the lesson of the day, and hopefully that will help you guys be able to do the practice problems on your own. And then at the end of the day, you guys will have an online session for your group, purple and green group. Will be separate, and you'll have time to ask questions and things that you were confused about, either in this lesson that I'm about to go over or on the practice problems. All right, so as I'm going through them, the best thing to do would be to pause and then try to solve the problem on your own and then see how I solve it. I'm not gonna like pause for you guys on my own and whatever, so the video won't be so long. So it's up to you guys to sort of pause it and then try to solve the problem and then see if you did it right after by checking with whatever I say. Okay, so some of you did this lesson 7 in unit 4, and some of you didn't. One of the groups did. I can't remember which, so we're just going to go over the whole thing, and some of you have some of it done, and that's awesome, but most of you don't. Okay, so on this slide, they're asking which one of these equations doesn't belong. So for each one of them, you could think of a reason and you can decide whatever you want, but they are all a little bit different, right? Like these two both have subtraction. This is multiplication and this is addition, right? So you could say that number 1 doesn't belong because it has addition. You could say number 2 doesn't belong because it has multiplication. Or you could say something about 3 or 4 not matching 1 and 2 because they have subtraction. They just wanted you guys to see the difference in the operations there. So that's all you have to worry about for that. All right, so which equation is true for all values and which one is true for no values? So this whole section is going to be talking about this all values and no values thing. So we might have talked about this a little bit, but what it means essentially is that all values is like I can plug in any number. So if you want to write a note down, you can. So all values means any number is true. And no values like literally just means no number will work, right? Does that kind of make sense? Okay, so for this first one, if you look at it, you have 2t plus 5 and you have 2t plus 5. No matter what number you plug in, they will be the same, right? So if I said, okay, what if t is 1? So 2 times 1 plus 5 equals 2 times 1 plus 5. So what is that? 7 equals 7. So if I were to pick a different number, like let's say I erase all this, and that's not going very fast. Okay, and then what if I say, I don't know, t equals 3. So then I could do 2 times 3 plus 5 equals 2 times 3 plus 5. You guys should get the idea. It's going to be the same, right? So 6 plus 5 equals 6 plus 5. Okay, so for this one though, if we look here, n plus 5 equals n plus 7, I can't pick a different value for each n, right? So like n has to be the same for the whole thing. So if I'm saying n equals 1, I would say 1 plus 5 equals 1 plus 7, 6 equals 8. That is definitely not true, right? Nope, does not work. So some of you I know are probably thinking, but why can't I just say that, you know, this n equals something and that n equals something so that they end up being equal? That would be great, but for equations, it always has to be that it's just that letter equals that number for that equation. So you can't, it never changes, if that makes sense. So whatever the letter is, it is the same value wherever it shows up on both sides of the equal sign. It's never going to be like sometimes n is 2 and sometimes n is 3. It's either 2 or 3 for that equation or whatever it may be, if that makes sense. Okay, moving on. So I wish I could say page numbers, but I don't have a book and I have no idea what page number this is, but we're somewhere in lesson 7 still, the second activity. So they want you to sort the equations into 2 types, so true for all values and true for no values. So that's essentially exactly what we did up here, right? Except you've got like, I don't know, 8 different problems. So we'll do a couple and then the rest of them I'm going to have you guys do on your own. And if you, I guess, get stuck or have questions and want answers for the ones that I don't go over, then that would be a time to ask me during the online group time at the end of the day. That's 1 o'clock and 1:35, I think. It says on the schedule. Anyways, so for the first one, let's look. So n equals n. I'm going to pick a random number. Let's just say I make n equal 1, right? So I could say 1 equals 1. Yep, that's totally true. So that means that all values would be true for this, right? Because I could also say n equals 2, and then I could be like, okay, so 2 equals 2. So this is all. So next to it, I could write all. Okay, so an equation like this, 2t plus 6 equals, you do distributive property, right? So I distribute my 2. So I've got 2t plus 6 equals 2 times t, oops, is 2t, 2 times 3 is 6. So right away, you can go and plug numbers in if you want, if that helps you. But if you have the same thing on the left side and the right side, you know that no matter what you plug in, it's going to be the same, right? Like 2t plus 6 equals 2t plus 6, it's the same. So I'm going to say all for that one. Okay, let's find one that's different. Okay, so if we look at this one down here, where the dots are showing up. Okay, so v plus 2 equals v take away 2. So let's say we make v 5. So 5 plus 2 equals 5 minus 2. So that's going to be hard to fit, but 7 equals 3. 7 and 3 are not the same number, right? So no, that is not true. That means that no matter what numbers I plug in here, it's not going to work, right? It's never, ever going to work. To be able to balance both sides of that and have the same answer, it's just the way it's set up. It won't make it equal, so you would just write none or no values or something like that. So what you're going to do on your own, you can pause the video right now or you can do it at the end. You're going to go back and do all of the ones that are blank that we did not do. You can do it. It's not that hard. Okay. Let's see. Write the other side of this equation so that this equation is true for all values of u. So what this wants you to do, and I'm going to set it up and have you guys finish it, so I'm not giving you all the answers, but they want you to take this equation and they want you to make it the same equation on this side because it wants it true for all, right? So like an example of one that's true for all, we have a couple, right? Like up here, I'll highlight it so you know what I'm talking about. This, right? That was true in the green. That was true for all. The only difference was on one side it was distributed, on the other it wasn't. So you could go, right, and start to distribute like this, and then you could start writing on this side like 6u minus blank plus blank, and then it would be the same thing, right? So I'm going to have you guys try to finish that on your own. All right, number 3, write the other side of this equation so that this equation is true for no values of u. So they're giving you the same equation to start, right? But this time it's no values of u. So that just means you're going to make it so it can never be true. So you want this side where I'm drawing this blank box must be different. Different values. So you could have, let's say, you distribute it, right? You're like, okay, that's 6u minus 12 plus 2, but I want to change it up. just enough. So I could say maybe I'm just going to make this side 6u minus, I don't know, 8. That would be different, right? Because it's not the same as 6u minus 10. So whatever you plug in, it wouldn't be equal, right? So I pretty much did that for you, but I hope you get the idea. All right. Is this answers? I'm not sure. Anyway, there's a slide there. Maybe it's answers, maybe it's not. I don't think it is. Alrighty. So I think we're on the last activity. They want you to fill in the blanks for the equation to make it either true or not true. So for number 1, they're saying they want you to make it so it's true for all values of x. So that's like up here, right? Like this green one that I highlighted, where it's the same on both sides, right? Like 2t plus 6 is 2t plus 6 or whatever. So 3x plus 6 equals, you literally have to make sure it's also 3x plus 6, right? So 3x plus 6 equals 3 times x, right? Because you distribute it. So a lot of you are going to hurry on things like this. You're going to be like, oh my gosh, 6, okay, done. But it's 3 times 6, right? So 3 times 6 is not 6. You'd want to go back and say, okay, 3 times what is equal to 6? And then that's what goes in your blank. So 3 times 2 would be making that, whoa, that is not what I meant to do. Interesting. Okay, cool. So 3 times 2 would be 6, correct? And then you got it for all values of x. I think that you can try to do the other two. C, this is what I would do for C, because it's a fraction and nobody likes fractions. Right away, you can do this. So you can go times 5, right? Even though this is all blank, you can still do times 5 just to get rid of your fraction. So then you have it looking nicer. So 15x minus 10 equals blank. That's what you're going to fill in, minus 10. Because 2 times 5 is 10, right? And I think you can figure out what goes in that blank. Should not be that hard. But whenever there's a fraction, just immediately get rid of it. Make it go away. Multiply by its reciprocal, right? Maybe I'll write that down for people who forgot. Reciprocal. Google it. Okay. Complete each equation so that it is true for no values of x. Okay, so really you can just write whatever you want here as long as it's not the same as the other equation. So like 3x plus 6. So it's going to be 3x, right? But you can make this number something else. So like 3 times what is not 6? So I could say, what about 1? 3 times 1 is 3, right? It's not 6, so that's going to give you a different value, which is what they're asking you to do. So then you're going to do the same thing for B and C, where you're going to just put in something to make it not true, which should be a lot easier than having to figure out how to make it actually true, if that makes sense. Okay. We don't need to read all of this, and we don't need to do this last problem. So at this point, you will go and finish all the problems that I talked about and didn't completely finish for you. And then you'll do your practice problems, even though like, yeah, that was homework in the past. But now, just so that you can get more help on what we're doing, I would try to do it before the time that we meet at 1 o'clock if you're in purple group and 1:35 if you're in green group. But if you don't do it until later in the day, that's totally fine. You can ask me old questions from the previous day, the next day, that I don't care. And you can also send me a message on Remind, and I'll get back to you pretty fast. So feel free to message me whenever you are stuck. I will respond throughout the day, since I'm just stuck in my house, like all of you. All right, I hope that made sense. People who are confused, or if I went too fast or should have gone over more problems, just send me a message and give me feedback so the next